Think about this for a moment. Every number you dial, every calculation you make, every step you take in this digital age is a testament to the genius of ancient mathematicians. We live in a world where mathematics is an integral part of our daily lives. It's in the way we tell time, measure distance, and even in the way we communicate. It's hard to imagine a world without numbers, without the precise language of mathematics guiding our every move. However, this world of numbers didn't just appear out of thin air. It was painstakingly built over thousands of years by great minds from ancient civilizations. From the towering pyramids of Egypt to the sprawling empire of the Greeks, each civilization brought with it unique mathematical insights that have shaped the world we live in today. The Egyptians, for example, were masters of geometry, using it to construct their monumental pyramids and temples. They even developed a system of numbers that's still in use today. But they weren't alone. The Babylonians, the Greeks, the Mayans, and many other ancient civilizations also made significant contributions to the field of mathematics. And it's not just about numbers and equations. These mathematical principles have found their way into various fields, from architecture and engineering to astronomy and computer science. They have formed the bedrock upon which our modern society stands, a testament to the enduring legacy of these ancient mathematicians. But why is it important to explore the history of mathematics? For one, it helps us appreciate the intricate beauty of the subject. It's not just about crunching numbers, but understanding the why and the how. It's about seeing the patterns, the connections, the elegance of it all. Moreover, it gives us a sense of perspective. It shows us that mathematics is not a solitary pursuit, but a collective endeavor spanning generations and civilizations. In the next few minutes, we'll be embarking on a journey through time, retracing the footsteps of these ancient mathematicians. We'll explore their world, their ideas, and their legacy. From the sandy deserts of Egypt to the bustling cities of the modern era, we'll see how mathematics has evolved and how it continues to shape our world. Join us on a journey through time as we uncover the mathematical legacy of ancient civilizations. Our first stop is the land of pyramids and pharaohs, Egypt. Culturally rich and historically significant, the Egyptian civilization was a cradle of numerous advancements, not least of which was in the realm of mathematics. Their number system, unlike ours, was based on 10, but didn't have a symbol for 0. Instead, they used different symbols for 1, 10, 100, and so on, which they would combine to represent other numbers. For example, the number 23 would be represented by 2 symbols for 10 and 3 symbols for 1. While it may seem a bit convoluted to our modern eyes, it was a system that served them well for thousands of years. This number system was not just for show. The Egyptians put it to practical use, particularly in the fields of architecture and surveying. The construction of their iconic pyramids is a testament to their mathematical prowess. These monumental structures required precise calculations to ensure their stability and longevity. The Great Pyramid of Giza, for instance, stands as a testament to the Egyptians' architectural and mathematical genius. The Egyptians also developed a form of geometry, driven by the need to re-establish boundaries washed away by the annual flooding of the Nile. This led to the creation of a rudimentary form of surveying, which relied heavily on mathematics. But the Egyptians didn't just use math for practical purposes. They also saw it as a way to understand the universe. They believed that Ma'at, the principle of balance, governed the world, and they saw mathematics as a way to maintain that balance. This philosophical aspect of Egyptian mathematics is often overlooked, but is a key part of their mathematical legacy. The Egyptians' mathematical journey was not just about numbers and calculations. It was a holistic approach that combined practicality with philosophy, creating a unique mathematical tradition that would lay the groundwork for future civilizations to build upon. As we leave the sun-drenched lands of Egypt, we carry with us the understanding of a civilization that used mathematics not just as a tool, but as a way of life. The Egyptians laid the foundation for mathematical concepts we still use today. Next, we travel to the cradle of civilization, Mesopotamia. This region, encompassing modern-day Iraq, was home to 2 of the most influential ancient civilizations, the Babylonians and the Assyrians. Both civilizations played a key role in the development of mathematics. The Babylonians and Assyrians were pioneers in the mathematical world. They developed a sophisticated number system that was unique for its time. This number system was based on 60, a base that is still evident in our 60-minute hours and 360-degree circles. The Babylonians and Assyrians were not just theoretical mathematicians, they were also practical problem solvers. They used their mathematical knowledge to solve everyday problems, from measuring land and calculating tax to predicting astronomical events. One of the most remarkable contributions of the Babylonians to mathematics were the clay tablets. These tablets were inscribed with cuneiform script, one of the earliest forms of writing. But these were not just historical records or works of literature. They were also mathematical textbooks, complete with problems and solutions. These clay tablets offer a glimpse into the mathematical world of the Babylonians. They reveal their understanding of algebra, geometry, and even a primitive form of calculus. They show us that the Babylonians had a deep understanding of mathematical concepts far beyond simple arithmetic. One of the most famous of these tablets is Plimpton 322. This tablet, dating back to around 1800 BC, contains a list of Pythagorean triples, long before Pythagoras was even born. This suggests that the Babylonians had a sophisticated understanding of geometry and the relationships between numbers. The Assyrians, too, made significant contributions to mathematics. They developed a complex system of weights and measures, and they used their mathematical knowledge to create accurate calendars and to predict lunar and solar eclipses. In conclusion, the contributions of the Babylonians and Assyrians to mathematics cannot be underestimated. They developed advanced number systems, solved complex mathematical problems, and left behind a wealth of mathematical knowledge inscribed on clay tablets. The Babylonians and Assyrians advanced our understanding of numbers and calculations. Now, let's journey to the birthplace of Western civilization, Greece. This ancient civilization, steeped in philosophy and arts, also significantly contributed to the development of mathematics. Greek mathematicians moved beyond the practical mathematics of the Egyptians and Babylonians, introducing abstract ideas and logical proofs that still underpin the subject today. One figure who stands out among the pioneers is Pythagoras. Although his famous theorem was known to the Babylonians, Pythagoras was the first to provide a logical proof. The Pythagorean theorem, stating that in a right-angled triangle the square of the hypotenuse is equal to the sum of the squares of the other two sides, remains a fundamental principle in geometry. The Greeks also gave us the concept of mathematical proof, which is still the foundation of mathematics. Euclid, often referred to as the father of geometry, compiled these proofs in his book, Elements. This text was so comprehensive and well written that it served as the main textbook for teaching mathematics right up until the 19th century. Euclid's Elements is a collection of definitions, postulates, propositions, and mathematical proofs of the propositions. The books cover not only plain and solid geometry, but also number theory. Euclid's method of proving theorems by logical deduction from clearly defined postulates became the basis for subsequent mathematical thinking. But let's not forget the genius of Archimedes, another great Greek mathematician. His contributions to the understanding of the principles of leverage and buoyancy are well known, but his mathematical work is equally significant. Archimedes was fascinated by numbers, infinity, and the concept of an infinite series. He used the method of exhaustion, an early form of integration, to calculate areas and volumes of geometric shapes. In fact, his work laid the foundation for the development of calculus centuries later. Archimedes' principle, the law of levers, and the Archimedean screw are just a few examples of his genius. His method of exhaustion, which essentially involves approximating an unknown quantity by a known one, is considered a precursor to integral calculus. Greek mathematics was essentially the birth of mathematics as we know it. The Greeks treated mathematics as a very important branch of philosophy, an approach that shaped the way mathematics has been approached ever since. Their influence is evident in the geometric architecture of their temples and in the abstract theories that still form the basis of mathematical thought. As we journey through the annals of mathematical history, it's clear that the Greeks played a central role in shaping this discipline. Their contributions were not merely in new findings, but in the way they approached mathematics as an art of logic, an art of reasoning, a tool for exploring the universe. The Greeks cultivated mathematics into an art of logic and reasoning. From Greece we cross the Atlantic to the Americas, home to the Mayan civilization. This ancient civilization, renowned for their architectural marvels and intricate calendar systems, was also a powerhouse in the world of mathematics. The Mayans were not just good with numbers, they were mathematical trailblazers. They developed a sophisticated number system that was one of the first to incorporate the concept of zero, a concept that was not even recognized by the sophisticated Greeks. Their number system was vigesimal, based on the number 20, a stark contrast to our modern decimal system based on tens. This system allowed the Mayans to express large numbers compactly, proving crucial for their astronomical calculations and calendar systems. Speaking of calendars, the Mayans were exceptionally skilled at tracking time. They developed several calendar systems, the most famous of which being the long count calendar, capable of measuring millions of years. The precision and accuracy of these calendars were astounding, all thanks to their understanding of mathematics. Their knack for numbers didn't stop there. The Mayans were also keen astronomers. They used their mathematical prowess to calculate the cycles of the moon, predict solar and lunar eclipses, and even track the path of Venus across the sky. These calculations were not only accurate, but also formed an integral part of their religious and cultural practices. The Mayans also applied their mathematical knowledge to their architecture. The precise alignment and intricate designs of their temples and pyramids are a testament to their mathematical skills. It's evident that the Mayans understood geometry and the importance of mathematical proportions in creating aesthetically pleasing and structurally sound buildings. The Mayan civilization may have declined, but their mathematical legacy lives on. Their understanding of zero, their vigesimal number system, their calendar systems, and their astronomical calculations all underline their significant contributions to the world of mathematics. The Mayans' understanding of mathematics was ahead of their time. Their mathematical achievements are a testament to the power of the human mind and its innate curiosity to understand the world around us. We now travel to the Middle East, where Islamic scholars made significant strides in mathematics. In the grand tapestry of mathematical history, the Islamic civilization occupies a vibrant and crucial thread. This period, spanning from the 7th to the 15th centuries, was a golden age for scientific advancement, and mathematics was no exception. Islamic scholars did more than just inherit knowledge from their predecessors. They built upon it, innovated, and in turn, shaped the future of mathematics. One of the most significant contributions during this era was the preservation and enhancement of ancient mathematical knowledge. Islamic scholars translated and studied texts from the Greeks, Indians, and Babylonians, ensuring that these valuable insights were not lost to the sands of time. Their efforts were instrumental in creating an intellectual bridge between the ancient and medieval worlds. In the realm of innovation, the Islamic civilization gave us one of the most fundamental branches of mathematics, algebra. The Persian mathematician Al-Khwarizmi is often hailed as the father of algebra. His seminal work, the compendious book on calculation by completion and balancing, introduced the systematic solution of linear and quadratic equations. This was a revolutionary leap from the geometric approaches of the Greeks, paving the way for modern algebra. Al-Khwarizmi's algebra was not just about abstract symbols and equations. It was a practical tool for solving everyday problems, from inheritance divisions to land measurements. His work demonstrated that mathematics could provide clear systematic solutions to complex issues. Beyond algebra, Al-Khwarizmi made significant contributions to other areas of mathematics. His work on Indian numerals, often known as Arabic numerals in the West, played a pivotal role in the adoption of our current number system, including the concept of zero. Translation efforts during the Islamic civilization also had a profound impact on mathematics. The House of Wisdom, established in Baghdad, was an intellectual powerhouse where scholars from diverse cultures and religions worked side by side, translating texts and sharing ideas. This vibrant exchange of knowledge allowed for the synthesis of diverse mathematical traditions and spurred further innovation. Moreover, Islamic mathematicians made significant strides in trigonometry, developing it into a discipline in its own right. They introduced the concept of sine and cosine, and Al-Biruni's work led to the accurate calculation of Earth's circumference. These advancements weren't confined to the Islamic world. As trade and travel flourished, so too did the spread of knowledge. Islamic mathematics reached Europe through Spain and Sicily, profoundly influencing the scientific renaissance that was to come. In the narrative of mathematical history, the Islamic civilization was a crucial turning point. It not only preserved and propagated ancient knowledge, but also made groundbreaking advancements, laying the foundation for modern mathematics. The Islamic civilization bridged the gap between ancient and modern mathematics. Next, we enter the era of rebirth, the Renaissance. This vibrant period spanning the 14th to the 17th century was a time of great cultural and intellectual transformation, and mathematics was no exception. The Middle Ages had been a period of relative stagnation in mathematical studies, with Europe largely cut off from the mathematical advancements of the East. But with the Renaissance, a renewed interest in learning and knowledge took hold. The ancient texts of Greek and Arabic scholars were rediscovered and translated, sparking a revival in mathematical studies. From the bustling trade centers of Italy to the scholarly halls of Oxford, mathematics began to flourish once more. Amidst this revival, there were a number of significant figures whose work left a lasting mark on the field of mathematics. One such figure was the polymath Leonardo da Vinci. Although best known for his artistic masterpieces, Da Vinci was also an accomplished mathematician. His notebooks, filled with geometric diagrams and equations, reveal a mind deeply engaged with mathematical problems. From investigating the properties of shapes to exploring the concept of proportionality, Da Vinci's mathematical studies intertwined seamlessly with his artistic pursuits. Da Vinci's work on perspective, in particular, showcased his mathematical brilliance. He used mathematical principles to create an illusion of depth and distance in his paintings, a technique that revolutionized the world of art. Moreover, his designs for various machines, including flying devices and war engines, demonstrated the practical applications of his mathematical knowledge. Another notable figure of the Renaissance was Nicholas Copernicus. A mathematician and astronomer, Copernicus proposed a radical idea that would forever change our understanding of the universe. Contrary to the widely accepted geocentric model, which placed the Earth at the center of the universe, Copernicus proposed a heliocentric model, with the Sun at the center and the Earth and other planets orbiting around it. Copernicus's heliocentric model was not just a philosophical proposition, but a mathematical one. He used mathematics to calculate the orbits of the planets and to predict their positions. His work, while controversial at the time, laid the foundations for modern astronomy and marked the beginning of a scientific revolution. The Renaissance was a period of great intellectual ferment and creativity. The revival of mathematical studies, the innovative work of figures like Leonardo da Vinci, and the transformative ideas of Nicholas Copernicus all contributed to a significant turning point in the history of mathematics. It was a time when old ideas were challenged, new concepts were explored, and the power of mathematical reasoning was harnessed to better understand and shape the world. The Renaissance period marked a significant turning point in the history of mathematics. From this era of rebirth, mathematics emerged, not just as a set of abstract principles, but as a powerful tool for exploration, innovation, and discovery. Finally, we arrive in the modern era, where mathematics continues to evolve. In the timeline of mathematical progress, the modern era brings us to the doorstep of some of the most influential mathematicians, such as Sir Isaac Newton and Gottfried Wilhelm Leibniz. Their work symbolizes the intellectual leap that humanity has taken in recent centuries, bringing us ever closer to understanding the universe's intricate design. Sir Isaac Newton, an English physicist and mathematician, is often celebrated for his laws of motion and universal gravitation. However, his contributions to mathematics are equally profound. Newton was instrumental in developing calculus, a branch of mathematics that deals with rates of change and accumulation. His method of fluxions was a pioneering step towards understanding how quantities change over time, a concept that underpins much of modern physics and engineering Across the English Channel, Gottfried Wilhelm Leibniz, a German polymath, was independently carving his path in the realm of calculus. Leibniz's notation, still widely used today, introduced integral and differential calculus as separate yet intertwined branches. This leap in mathematical language provided the tools for future generations to explore the complexities of motion, area, and volume. But why does calculus matter? Well, it's the mathematical powerhouse driving many areas of our contemporary world. From the physics that launch rockets into space, to the economics that predict market trends, to the biology that models population growth, calculus is the hidden hand guiding our understanding. The modern era didn't just stop at calculus, though. Mathematics continued to proliferate into various sub-disciplines, each with its unique challenges and breakthroughs. The advent of computers gave rise to new fields like computational mathematics and data analysis. Meanwhile, the mysteries of the quantum realm spurred developments in mathematical physics. In a sense, the modern era is a testament to the cumulative power of human curiosity. Each new mathematical discovery builds upon the foundations laid by ancient civilizations, refined through the ages by thinkers from across the globe. The story of mathematics is, in many ways, the story of humanity's relentless pursuit of knowledge. In this era, we also see an emphasis on the beauty and elegance of mathematical proofs. Mathematicians like Andrew Wiles, who solved the centuries-old Fermat's last theorem, and Grigori Perelman, who cracked the Poincare conjecture, remind us that mathematics is not just a tool for science and technology, but a form of art in its own right. As we journey forward, we can expect mathematics to continue evolving, unlocking new dimensions of the universe and the human mind. The story of mathematics is far from over. In fact, we might say it's just getting started. The modern era has seen the most rapid advancements in mathematics. As we end our journey, let's reflect on the legacy left by these ancient civilizations. The footprints of these societies in the sands of time have shaped our mathematical understanding, providing a solid foundation for the modern world. From the banks of the Nile, the ancient Egyptians gave us a glimpse into the practical applicability of mathematics. Their number system and hieroglyphic representations, seamlessly integrated into their architecture and surveying, set the stage for the mathematical advancements to come. Next, the Babylonians and Assyrians, with their advanced number system and base 60 calculations, offered us a profound understanding of time and space. The clay tablets they left behind serve as a testament to their mathematical prowess, their calculations standing the test of time. The Greeks, often seen as the pioneers of Western mathematics, introduced us to Euclidean geometry and the Pythagorean theorem. The monumental works of Archimedes, including his contribution to calculus, continue to inspire mathematicians to this day. Across the Atlantic, in the lush landscapes of Central America, the Mayans developed a sophisticated number system, incorporating the concept of zero. Their intricate calendar system and astronomical calculations reflect a deep understanding of the cosmos, far ahead of their time. The Islamic civilization, often overlooked, played a crucial role in preserving and advancing mathematical knowledge. Scholars like Al-Khwarizmi introduced algebraic concepts that form the backbone of modern mathematics. Through their translation efforts, they ensured the continuity of mathematical development. Then came the Renaissance, a period of revival for mathematical studies. Leonardo da Vinci's mathematical works and inventions, along with Nicolaus Copernicus's heliocentric model, laid the groundwork for a new era of scientific exploration. In the modern era, figures like Isaac Newton and Gottfried Leibniz further advanced the field of mathematics. The development of calculus has had a profound impact on various fields, from physics to economics, shaping our understanding of the world. Each of these civilizations, in their unique ways, contributed to the rich tapestry of mathematics. Their lasting legacy continues to inspire and guide future generations. Like a relay race across the ages, they've passed on the baton of knowledge, each civilization adding to the strides made by the ones before. Understanding the history of mathematics allows us to appreciate its development and significance. It helps us see that mathematics is not just a collection of numbers and equations, but a human endeavor that transcends cultures and epochs. It's a testament to our inherent desire to understand the world around us, to make sense of the seemingly random, and to find order in chaos. The journey continues as we keep building on the foundations laid by these ancient civilizations. As we stand on the shoulders of these mathematical giants, we strive to reach higher, to uncover new truths, and to further our understanding of this incredible universe. Our journey through the ages of mathematics may have come to an end, but the story of mathematics is far from over. It's a story that's still being written, one equation at a time.